Happy Teachers Day. On the occasion of Teachers Day, I would like to remember my school teachers and intermediate lecturers and degree lecturers. School teachers, Raghav Sharma garu, who was my brother, and Prabhakar Rao garu, Lakshmi Narayana garu, headmaster. When I was in 10th class, Lakshmi Narayana garu was the headmaster, and Rukmaya garu. These are the mathematics teachers. Prabhakar Rao garu and Rukmaya garu were my mathematics teachers. And intermediate lecturers, Ramana garu and Chandra Reddy garu, who taught me mathematics. And in degree, book writer Raghavendra garu. I would like to remember all of the teachers and lecturers who taught me and inspired me in teaching mathematics. Thank you very much. Happy Teachers Day. Last problem in IIT Foundation and Olympiad questions, 25th problem. If 4, 7, 10, 13 and so on 502, 502 and 1, 8, 15, 22 and so on 498 are two arithmetic progressions, then find the number of terms that are common in both progressions. We have to find number of identical terms in both progressions. To understand this problem, I will take one example. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. I am taking another progression starting from 10, 10, 20, 30, 40 and 50. How many pair of identical terms in both the series? The common difference, here common difference d is equal to 5. Here common difference is 10. This is in AP and also this progression is also in arithmetic progression because common difference is same. 10 minus 5, 5. 15 minus 10, 5. Here also common difference is same. 20 minus 10, 10. 30 minus 20, 10. 40 minus 30, 10. Common difference is same. Two progressions are there. We have to find pair of identical terms in both progressions. What are the pair of identical terms? You see, this is, I will write A1, A2, A3, A4, A5, A6, A7, A8, A9, A10. How many terms are there? 10 terms are there. And I will take here also A1, A2, A3, A4, A5. How many terms are there? 5 terms are there. We have to find the identical terms and also the number of identical terms. This is A2, here A1. Pair of identical terms. One pair, 1. 15, 20. 20 is there. A4 and A2. These two are identical terms. Pair of identical terms. 25, 30. A3. Here sixth term and their third term are equal to each other. 8th term and 4th term. And lastly 10th term and 5th term, they are equal to each other. How many terms are there? Identical terms. A2 is equal to A1. It's a pair of one pair of identical terms. Another one, A4 is equal to A2. A6, in this one, A3, they are identical to each other. And 8th term is equal to 4th term. Lastly, 10th term and 5th term are equal to each other. How many pair of identical terms? How many terms are there? 1, 2, 3, 4, 5. 5 pair of identical terms in both progressions. In both APs. In this progression, how many terms are there? 10 terms. 10 terms are there. Here, how many terms are there? 5 terms are there. 5 terms only identical, because here we have 5 terms, and even though we have 10 terms, only 5 terms are identical in both progressions. Now we will go to that problem. First we have to find how many terms are there. How many terms are there in that progression, so that we can understand how many terms we have to take in both progressions, and find number of pair of identical terms. First you have to find number of terms in this progression and number of terms in this progression. See, I will take 4, 7, 10, 13 and so on, 5, 0, 2. We will find out from last term, we can find out the number of terms. Let number of terms be x. X. What is the last term? From last term we will find out the number of terms, that is x. 502. What is the formula for last term or nth term? A plus n minus 1. How many terms are there? X terms are there. That's why I am taking x minus 1. Instead of n, I am taking x. X minus 1 into d. Next. A. What is first term? 4 plus x minus 1. We have to find the number of terms. D. What is D here? 7 minus 4, 3 is equal to 502. 4 plus 3x minus 3 is equal to 502. 4 minus 3, 1. 3x plus 1 is equal to 502. 3x is equal to 502 minus 1. X is equal to 501 divided by 3. 3 ones are 3, 20. How many times it will go? 3 6 are 18. 3 7s are 21. Number of terms in the above series is 167. Now, let us find the number of terms in this series 1, 8, 15, 22 and so on 498. Let the number of terms be y. Be y. Now, what is the formula we have? This is last term. Check whether they are in AP or not. 8 minus 1, 7. 15 minus 8, 7. 22 minus 15, 7. Common difference is same. So, this progression in arithmetic progression. Now, what is the number of terms? Y. A plus y minus 1 into d is equal to last term is 498. Last term and nth term are same. A. What is A here? 1 plus y minus 1. We have to find the number of terms from last term. D. What is D here? 8 minus 1, 7 is equal to 498. 1 plus 7y minus 7 is equal to 498. 7y minus 6 is equal to 498, and you will get 7y is equal to 498 plus 6. 7y is equal to 7y is equal to, you will get 7y is equal to 504 and y is equal to 7 sevens are 7 twos are 14. How many terms are there? 72 terms. How many terms are there in this one? 167. Number of terms. X we have 167 and y number of terms we have 72 terms. This progression is having 167 terms, whereas this progression has 72 terms. Pair of identical terms will be less than or equal to 72. Now, to find the pair of identical terms, let us take nth term of this series equal to nth term of this series. Now we have to find the number of identical terms in both progressions. For that one, let us take nth term of this series is equal to nth term of this series. Now I will rub the board and continue the problem. Number of terms in this progression we have 167 and number of terms in this progression we have 72 terms. Number of terms that are common in both progression will be less than 72. This you should remember. Now nth term of this progression 4, 7, 10, 13, 502 is equal to nth term of this progression 1, 8, 15, 498. See, nth term means a plus m minus 1 into d is equal to a plus nth term of that progression means a plus n minus 1 into d. Now, what is a here? 4 plus m minus 1. We have to find d. What is the difference? That is 3 is equal to, in that progression, nth term of that progression will be a will be 1, n minus 1, d will be 8 minus 1, 7. We have to equate these two so that we will get a number of terms which are identical to each other. 4 plus 3m minus 3 is equal to 1 plus 7n minus 7. 4 minus 3, 1. 3m plus 1 is equal to 7n minus 6. This can be written as 3m is equal to 7n minus 6 minus 1. You will get 3m is equal to 7n minus 7. 3m is equal to, take 7 common, n minus 1. Now this can be written as m by 7 is equal to n minus 1 by 3. 7 into n minus 1, 7n minus 1. 3 into m, 3m. Let us take this is equal to k, because we have to find the number of terms m in terms of k, so that we will get the pair of identical terms in both the series. Now m by 7 is equal to k. This can be written as m is equal to 7k. Now 7k is equal to m. 7k is less than 72 terms. K is less than or equal to 10. We have to take less than 72 only because we have only 72 terms are there in this progression. That's why I have to take 7k is less than 72 and k is less than how many times? 10 times. You will get 2 by 7. Next. Now you have to take n minus 1 by 3 is equal to k. N minus 1 by 3 is equal to k implies n minus 1 is equal to 3k. Now I have to find n. 3k plus 1 is equal to n. 3k plus 1. N is number of terms you have to take less than or equal to 72. Now 3k is less than, you take like this, 71. K is less than or equal to 3 2s are 6, 11, 3 3s are 9, 2 by 3. The terms will not be in fractions. That's why it is k is less than 10 terms, and here k is less than or equal to 23 terms. Here k is less than 10. Here k is less than 23. But we have to take k is less than 10 terms we have to take. Like that, k is equal to 1, 2, 3, 4 up to 10 terms you have to take. Corresponding to each value of k, we get pair of terms that are common to both the series. Corresponding to each value of k, we get pair of identical terms. Now verification. Now 7k, in this one 7k we have to take 7 into 1. How many terms are there? How many terms are there? 7k means 7 into 1 we have to take. 7 into 1. How many terms are there? 7 terms are there. M is equal to 7. 7 terms means A7. I have to take A7, which is identically equal to, substitute k is equal to 1 here in 3k plus 1. K is equal to 1 here. 3k, 3 into 1 plus 1 is equal to n, means 3 into 1 3, 3 plus 1 4. 4 terms. 4 terms means I have to take A4. A7 in this progression equal to A4 in this progression. What is the meaning of it? 7th term is equal to 4th term in this progression are equal to each other. 4th term. Now 7th term. Let us find 7th term in this progression. 7th term means a plus 6d is equal to a plus 3d. Now 7th term in this progression equal to 4th term in this progression. See, because k is equal to 1 we are taking. Now a means 4. 4 plus 6 into d. 6 into 3. 4 plus 6 into 3, 18 is equal to a plus 1 plus 3 into d. D will be 7. 1 plus 3 into 7, 21. 1 plus 3 into 7, 21. See, 4 plus 18, 22. And 1 plus 21, 22. Like that, 7th term of this progression is equal to 4th term of this progression, because a pair of one pair. We got A7 is equal to A4. This is one pair of identical terms. See, one pair of identical terms. How many pairs of identical terms will be there? 10 pairs of identical terms will be there. Identical terms in both APs means progressions. Like this we have to do. We have to take this is equal to k and find the number of terms in terms of k, and they should be less than 72, and here also we have to take less than 72 so that we can find the value of k. Corresponding to each value of k we get pair of identical terms. That is, if you substitute k is equal to 1 here, you will get number of terms. K is equal to 1. Number of terms you are getting. Number of terms means 7 terms. Seventh term you have to find. And here you have to substitute k is equal to 1 because we have to find the pair of identical term. K is equal to 1. K is equal to 3 into 1. 3. 3 plus 1. Number of terms you will get 4. 4 terms means fourth term, and like that seventh term in this progression equal to fourth term in this progression. This is one pair of identical term when k is equal to 1. If you substitute k is equal to 2, you will get another pair of identical terms. Like that we have 10 terms. 10 pair of identical terms will be there in both progressions. I think you have understood the problem. This is the last problem in progressions, and I will give you practice questions and objective type questions. Part D will be practice questions and object type questions from my book written by me, A Conceptual Approach in Learning Mathematics for class 10th, CBSE and also state boards. Practice questions. Practice questions. Very short questions. Short questions and essay questions and object type questions with answers.